All right, so we are going to really kind of dive into these triangle proofs. So to prove triangles are congruent, your last statement is the names of the triangles. So like triangle ABC is congruent to triangle MNP, and your justification is one of these. So either side, angle, side, angle, side, 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 angle, angle, side, or HL. That is the only justification you can use if your statement is talking about the two triangles being congruent. So we're going to go through just like a regular proof. We're going to identify information, things that are congruent, things that we know, maybe right angles. And then our final statement should be that the two are congruent. So let's look at our first example, a nice little fill in the blank to kind of start us off. We have K is the midpoint of LM. So I like to, as you know, go through and mark the stuff in my given. And of course, K is also the midpoint of JH. So we know those two pieces are congruent. So this is all a part of my given. Remember, that's always your first justification. So when a given talks about the midpoint, I know for a fact I'm going to use definition of midpoint. Like that, it is always going to happen. So looking at our first given statement, we have LK is congruent to KM, and we know that by definition of midpoint. So what else could we say? Our next statement is empty for us, but they told us, hey, you're going to use definition of midpoint. Well, we had a second midpoint with a second line segment, and that was with JH. So because K is the midpoint of line segment JH, I can also say that JK is congruent to KH by definition of midpoint. That's great. So our last bit, well, we're going to try to either use side, 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 angle, side, angle, one of these. So looking at what's given, I know two sides. So I'm going to use one of my justifications that uses two sides. So let's look at the list here again. We're either going to need to prove that the third side is congruent, but I don't think we have any information to help us with that. Or I'm going to need to do side, angle, side. So remember that angle for side, angle, side has to be included. It has to be in between the two sides. So look at where your two sides are and what angle is included or in between these two. Well, we have angle LKJ and angle MKH. So if I look at these two, I think these two are congruent because of vertical angles theorem. So I'm going to say angle LKJ is congruent to angle MKH. Again, following the correct path. If I started at L and I go down that line to K, that is congruent to the line segment MK. So I need to use that line segment first in naming that angle. So now we've used side, angle, side. So my justification is SAS, or side, angle, side. Let's try another one just to get y'all comfortable. We've got XT, line segment XT, bisecting angle EXK. So if it says bisects, I know I'm going to use definition of angle bisector. And what that's doing is cutting this angle into two congruent pieces. I'm also told that XE is congruent to XK, so XE is congruent to XK. So all of that's a part of my given. It tells me I'm using definition of angle bisector, like I said. So that tells me that angle EXT can be congruent to angle KXT. And if you name them slightly differently, that's fine. You could say angle TXK and TXE. That works as well. And then reflexive property. Reflexive property tells us that something is congruent to itself. So looking at our drawing or our diagram, what is congruent to itself? What is lined up with itself? Well, XT is lined up with itself. So I can say line segment XT is congruent to line segment XT by reflexive property. And then if we look at what we have a side, we have an angle, we have a side, we have a side, we have an angle, we have a side. So by side, angle, side, again, our two triangles are congruent.